Hi, welcome back. Today we're going to continue our unit on matrices. We are going to specifically talking about determinants. So a determinant is a number associated with any square matrix. And so it's kind of like we'll use the notation of the straight bars. So it'll look like saying we're doing the absolute value of a matrix. And it's going to get us a single constant for each square matrix. So only 2 by 2s, 3 by 3s, 4 by 4s, and so on. So let's assume that A is A, B, C, D. Its determinant is going to be the constant of A times D, so that downward diagonal, minus B times C, the upward diagonal. Okay, so for this matrix, the determinant of A, or you could also write it in this notation, would be 2 times 5, that's the downward diagonal, minus 3 times negative 4, that's the upward diagonal. So we get 10 plus 12, and that's 22. Now this is really nice for 2 by 2s. They're pretty quick and easy. But as the matrix gets bigger, it gets a little more complicated. So for 3 by 3s, we have two different methods. Method 1 is by using the diagonals. So the main diagonal is this 1, 4, and 2. So I'm going to multiply those together. Okay, then I'm going to do all the other downward diagonals. Now each diagonal has to have 3 pieces. So you'll notice this one is going to be 2 times 5, but then it's missing something. Well, what it does is it wraps around. So basically you can go ahead and rewrite column 1 here beside it, and you'll fill in that diagonal. Okay, and then we're going to do the third diagonal, which is going to start with this 3, and it is also going to wrap around. So we could also go ahead and write the next column here, and then we'll fill in the rest of that diagonal, and we get 3 times negative 2 times negative 1. Okay, so altogether that's 8 plus 30 plus 6. Okay, now we're going to come back and we're going to do the same thing with the downward diagonals. Okay, so we're going to take, we just did the downward. Now we're going to do the upward. So the main upward diagonal is 3 times 4 times 3. The next one is negative 1 times 5 times 1. And the last one is 2, negative 2, 2. And so we're going to add those together, and that's going to be 36 minus 5 minus 8. So that gives us, 31 minus 8 would be 22. 23. And so then what we do in 2 by 2s, we took the downward diagonal minus the upward diagonal, right? So down minus up. So we're going to do the same thing here. So I'm going to take all of these upward diagonals, and I'm going to subtract all of the downward diagonals. So what we end up with is 44 minus 23, or a determinant of 21. Now this method only works for 3 by 3s. As we get bigger, we have to use method 2. Method 2 is called the cofactor method. So I'm going to start by picking any row. You could actually pick any column as well, but we're going to pick a row. So I'm just going to start with the top row. And I'm going to form what we call a cofactor for each of those values. So 1, 2, and 3. Okay, so the cofactor for the 1 is formed by getting rid of that column and forming its minor matrix here. So 4, 5, -1, 2. Okay, and then I'll take the determinant of that. So that'll be 4 times 2 minus 5 times -1. So I get 1 times 8 plus 5, which is 13. Okay, then I'm going to take and do this same thing for the 2. Now the 2 is in column 2, so I'm going to get rid of column 2, and I'm going to form the minor that's left over. So that'll be -2, 5, 3, 2. And then I'm going to take the determinant of that. So that'll be -4 minus 15. So that's going to be 2 times -19. Okay, and then we do it again for the 3. So now I'm going to get rid of column 3 where the 3 is, and I'm going to take its minor. So that'll be -2, 4, 3, -1. And I find that determinant. So I'll have 2 minus 12. Okay, remember diagonals. And so that gets me 3 times -10. Now, remember, when we did the 2 by 2s and even the diagonal method, again, it was down diagonals minus up. So in this case, some of this information that we just found has to be subtracted. Well, how we decide that is by looking at where this number is located. So this is in row 1, column 1. So this cofactor is going to be multiplied by -1 to the 1 plus 1 power. So that's -1 squared. So that's a +1. So I end up getting 13. The 2 is in row 1, column 2. So now I do -1 to the 1 plus 2. Well, that's -1 cubed. So I get a -1 out front. So I have a minus here. So I get a +38. Okay. And then the last one, the 3, is in row 1, column 3. So now I do -1 to the 1 plus 3. Well, that's -1 to the 4th. So that's a +1. So now I get a +3. So you'll notice I have a plus and then a minus and then a plus. Now that is not determined by the numbers that are inside here. Just plus, minus, plus. If I had a 4th one, it would be minus and then plus and then minus and so on. Okay, so then all we do is we add up the end results. So 3 and 8 makes 11. And then I have, oh, sorry, we're going to subtract the bottom one. So that would be 11 minus the 0. And then, so let's see, we end up with 51 minus 30, because this is 51, and so I still get 21. So the same result regardless of the method that we use. Now as I get bigger, I have to use cofactor. So I'm going to choose a row wisely. If there are any zeros, we want to choose that row, because then one of the cofactors is going to go away. So I'm going to do 2 times negative, let's see, then I'll take this minor. So I'll have 1, 3, 4, 2, -1, 1, 3, 2, 2. And that's in row 1, column 1, so this will be positive. Okay, then we're going to take the -1, and we're going to do its minor. So that'll be 2, 3, 4, 1, -1, 1. and 4, 2, 2. And that's row 1, column 2, so that one's going to be minus. And then I'll add the next one is 0. So it doesn't matter what its minor is because it's 0. Okay, and that one would be plus. And then I take the 2 and I do its minor. So I'll have 2, 1, 3, 1, 2, negative 1, 4, 3, 2. And the first one was plus, the second one is minus, and then plus, so this one is minus. Okay, and now we can just find each of these determinants and get our value. Now we can do these 3 by 3s using the diagonal method or the cofactor method, your choice. And then you just get these values and then you'll get your answer. Now you can start to do some of these determinants in the calculator. If you have a TI-83, you're going to do second and then you're going to do the X to the -1 button, because above that button it says matrix. Okay, and then you're going to go to math, and option 1 says DET, and so you can find the determinant of your matrix. Okay, so try that out. Maybe next time I'll do a video on just the calculator usage, but hopefully that helps on how to find matrices. My next video is going to be on using these determinants to solve systems of equations using Cramer's rule. So hopefully you'll join me there. Feel free to subscribe, and I will see you next time.